Alright, so I'm going to pick up where Mr. Polotasig stepped out for the chain rule. So the chain rule, let's put it right here, is, and I define my functions a little differently than he does. So I'm going to use a capital F to represent the entirety of the function. Then I'm going to use lowercase to say what it represents. So f of g of x. So there's a function within a function is essentially what's happening here. So I can say f prime of x, which is taking the derivative of this, is f prime of g of x, g prime of x. So in other words, what we're doing is we're taking the derivative of the outside function, and then we're multiplying by the derivative of the inside function. Right here we're leaving g of x alone, and I'll kind of show you how we're doing that. Some people like to think about it as use substitution, so that's the way we are going to give it a try. So, example, I'll do a quick one right here. If we have, let's say, 3x plus 2 squared, then we have a function within a function, right? This, we could define g of x, well, let's just do it. Let's say that f of x, and this is where the u substitution is. So we're going to call x plus 2 u. Let's actually just do that. So x plus 2 we're going to define as u. So in that case, f of x, or f of u rather, could be called 3u squared. That we can do via normal power rule, right? We can pull that number to the front and reduce this by 1. So if we wanted to take f prime with respect to u, that would be 6, right? 3 times 2, and reduce the power by 1. 3 minus 1 is 1. We also can define the inner function, remember how we're doing this, as g of x. So g of x. We're not going to use substitution for that. It's just a placeholder. Normally use substitution is used for integrals, but I'm just going to give you an introduction to the concept of using a placeholder. So if we have g of x equaling x plus 2, then g prime x would be equal to, we pull the 1 down. This doesn't have any power, so it would be erased. The constants get eliminated when we take a derivative. This had essentially x to the 1. So that would be brought to the front, and x to the 1 would be x minus 1 minus 1, x to 0 is just 1. So again, the 2 is going to get eliminated because it's constant. 1 is going to be brought to the front. The power is going to be reduced to 0, and anything to a 0 power is 1. 1 times 1 is 1. So what we have here, if we're going to plug it all into the chain rule now, is f prime of x is equal to, let's actually define this, so then f prime of x, if we plugged it back in, would be 6, oops, would be 6, and then remember that u was represented by x plus 2. So f prime of x is equal to f prime of g of x, which we have right here, times g prime of x, which is just 1. And we can distribute that through to become 6x plus 12. So we didn't have to do this. We could have just left it as x plus 2 on the inside and not touched it. But I just want to give you the idea of using a placeholder. But anyways, what we got is we took the derivative with respect to the outside, which is to pull the 2 to the front and reduce the power by 1, and then multiply it by the derivative of the inside, which we found to be just 1. Should have probably actually defined this as well. F of x equals, so f of x equals 3x plus 2 squared, and actually we can go ahead and do another example now that we're more familiar with the concept. So problem 2, we're going to define f of x as, let's say, 2 times 2x squared plus x cubed. I'm being careful to only do the chain rule here. That's why the problem looks relatively similar to the last one, because once we start getting too complex, we're going to have to put multiple rules together. And you're not really going to have to do that on the praxis. So if we do this, we take the derivative with respect to the outside, so that's going to become, pull the 3 to the front, 2x squared plus x, reduce the power by 1, multiplied by g prime of x, which is the inside, so 2 times 2 is 4, reduce the power, that's just going to be x, so multiplied by 4x, and then that's just going to become 1. So we took the derivative of the outside, left the inside alone, multiplied by the derivative of the inside. So this satisfies our f prime of g of x, g prime of x then. And we could distribute it and simplify and all of that, but the fact of the matter is this is our derivative with respect to x. And we're done.